Welcome to this video. I'm Evinov and I'm here to introduce you the build of the Replica3D V4, my homemade 3D printer. I conceptualized and designed it from scratch, starting with sketches on paper, then creating a digital model in SolidWorks, and finally bringing it to life. Let me explain to you how it is built. Firstly, let's take a look at the structure of this printer. As you can see, it is a combination of printed parts and aluminum extrusions. I choose a modular aluminum structure because it is lightweight and easily upgradable. The printed parts are made from premium orange PLA supplied by 1 France. The idea behind this choice is to have a lightweight and cost-effective structure while maintaining robustness, especially in the case of mass production. One of the crucial aspects I considered in building the Replica3D V4 is the printable volume. I aim to achieve similar characteristics in terms of printable volume as the best printers available on the market. Although I intended to have a surface of 300 mm square and a height of 300 mm. For structural and security reasons, the printable surface is finally limited to 270 mm cube. Nevertheless, this is still an excellent size that allows for a wide range of prints in various dimensions. Moving on, let's discuss the printed surface. I opted for a glass surface, but not just any glass. I chose the ultra base surface, which is a glass plate with numerous microscopic holes. These holes help the small parts of the fused filament adhere to the surface during printing, preventing them from moving around. But that's not the only improvement in the V4 version. We have also incorporated a heated bed. The aluminum surface just below the ultra base is known as the heated bed because it can reach temperatures of up to 150 degrees depending on the type of filament being used. For example, PLA can be printed at a bed temperature of 50 degrees while carbon requires temperature between 90 and 110 degrees. The combination of the ultra base and the heated bed is referred to as the bed. Underneath the bed, there is an aluminum insulator that helps maintain the bed's temperature and conserves heating energy. Below the bed, we have a polycarbonate plate and 4 red nuts that can be adjusted to level the bed. This leveling process is facilitated by a sensor, which we'll discuss later. Furthermore, this 3D printer operates on 3 axes, the X, the Y, and the Z axis. Each axis is driven by a NEMA 17 stepper motor. To ensure precise layering in prints, especially for the crucial first layer, I have equipped the Z-axis with 2 motors. Those who have experience with 3D printing will understand the importance of achieving good print layers. To mark the starting points on the X and the Y axis, we have installed end stops, which function as sensors that establish an offset or home position for the respective axis. Now, let's get back to the stepper motors. The Y-axis motor controls bed movements, the X-axis motor controls the Hotend, and the Z-axis motor controls the height of the Hotend. Lastly, we have the Extruder motor located at the top of the printer. As you may have noticed, the motors are not alone. Each motor is accompanied by a heat dissipator at the back to remove excess heat and a damper at the front to prevent motor vibrations from affecting the printer's structure. This improvement significantly reduces the overall noise generated by the printer. Additionally, I have selected one of the best motor drivers available for this printer, the TMC 2209 version 1.2. These drivers subdivide motor steps, dividing each rotation of the motor into 200 steps. Thanks to the TMC driver, each of these 200 steps is further divided into 256 microsteps, ensuring high precision in axis movements. Now, let's move on to the most exciting part of the printer, the Hotend. It's undoubtedly the part that enables you to print anything you want using any type of material at any time. I particularly like the designs of this Hotend because it proudly features the Evinov logo. But let's dive into the technical details. At the bottom, you can see the nozzle. This is the vanadium nozzle from Slice Engineering, one of the leading manufacturers of Hotends in the world of 3D printing. Another well-known manufacturer is the E3D. This nozzle is specially designed for a high-temperature printing. With its robust construction and ability to withstand temperatures up to 500 degrees, it ensures durability and reliable performance. For instance, you can print with carbon or even metal materials using this Hotend. Above the nozzle, we have the heater block. This is where everything begins. The block houses a 50-watt heater that can reach the desired temperature based on the material being printed. It also contains a PT100 thermistor capable of detecting temperatures up to 300 degrees. In this block, the filament you want to print undergoes fusion before being deposited onto the bed surface. Within the Hotend, you can see a 24-volt cooling fan, and behind it, although not clearly visible, is a heat dissipator. The purpose of the fan and dissipator is to keep the filament solid before it reaches the heater block. Only within the heater block does the filament melt and become ready for printing. Another notable feature on this Hotend is the leveling sensor, which I mentioned earlier. It's a 3D touch sensor. When you command the Z-axis to go to the home position, a small sting extends from the sensor to touch the bed surface and determine its level. Let's talk about the extruder located at the top of the printer. It's a simple system consisting of a motor and gears that grip the filament from a spool and guide it through the blue pipe until it reaches the Hotend. Above the extruder, you will find another sensor called the filament runout sensor. Its operation is straightforward. It works as an interrupter. When the filament is present, the sensor detects it, enabling the extruder to push the filament through the pipe. However, in the absence of filament, the interrupter remains open and the extruder doesn't attempt to fit filament. Finally, the material used for printing comes from a spool mounted on a holder located at the back of the printer. Within the base of the Replica3D structure on the right side in a box, we have a 350-watt power supply, and on the left side, also in a box, is the printer's circuitry, which includes the Big3Tech SKR V1.4 Turbo mainboard. This mainboard is considered one of the best available in the market. To command the printer, we have a touchscreen interface that allows us to perform various actions, such as moving the axis, starting or stopping a print, and monitoring ongoing prints. We can adjust the temperatures of the bed and the Hotend, test different printer components, and more.